This is problem number 15. I can tell that this one is an absolute value because of the V shape. So my original absolute value is over here. This is the parent function for the absolute value. And its table looks like this. -1, 1, 0, 0, 1, 1. Okay, that's the table for the original parent function. Okay, so let's look for the shift. We go 1, 2, 3, 4, 5, 6, because we're trying to go from this point to this point. So 6 to the left. So that's a horizontal shift, left 6 units. 6 units. And then we went down 2, so that's a vertical shift, down 2 units. Okay, so we went left 6, down 2 to get from this point to that point. Now we've got to check for our stretch and compression. So we're going to check these points. We're going to pretend this is a new origin. So this is my new point 0, 0. This is the pretend origin. And we're going to go to the left 1 and up 1. Left 1 and up 1. Okay? Left 1, up 1. That point is not on the graph. 0, 0 is right 1, up 1. That point is on the graph. All right, so what I need to do now is make a new table. I'm going to say, well, let's see what happens if I go left 1. If I go left 1, here's the point that's on the graph. Okay, well this is 1 unit. You can see that's between -1 and -2. So this is 1 unit. So these are divided into quarters. Okay, so this is left 1 up 1/2. So left 1 up 1/2. This is 0, 0. It's still on there. And this is right 1 up 1/2. So I notice that my x's are the same. My y's are being multiplied by 1/2. So that is a vertical compression by a factor of 1/2. Okay? So, but that's not the only answer. And I'm going to do the other one so in case you see it and you want to do it. If I wasn't positive that this was 1/2, then I could have gone right over here to this point and right over here to this point. And I could have said, what is that point? That's to the left 2 and up 1. So left 2 and up 1. 0, 0 is still on the graph. What is this point? It's right 2 and up 1. So this time I can see that my y values have stayed the same and my x values have been multiplied by 2. So my x's here, x's were multiplied by 2. So I could have, instead of writing this, I could have written over here a horizontal stretch by a factor of 2. Okay, now I don't want to confuse you. These two always apply. So it's these two and this one, or you could have had these two and this one. Okay, and on the test I would have counted either of those correct. Okay, that's 15. Now we're going to go to 16. Okay, problem number 16 looks like this. It's a quadratic. So I'm going to start out with my parent function. I know the quadratic parent function. Its table looks like this. -1, 1, 0, 0, 1, 1. So it's here, here, and here. So let's look at this shift. I've gone to the right 1. So that's a horizontal shift, right 1 unit. And then from there I went down 1, 2, 3. So that's a vertical shift down 3 units. Okay? Now I need to check on my stretch and compression. So I'm going to make my pretend origin right here. So this is my new pretend point 0, 0. And then I'm going to check these points. So negative 1, 1, definitely not on the graph. 0, 0 is on the graph. And over to the right 1, up 1, definitely not on the graph. So now I'm going to find out what points are on this graph. So I'm going to go to the left 1, up 1, 2, 3, 4 until I get to a point that's on the graph. So left 1, up 4, 0, 0 is on the graph, right 1, 1, 2, 3, 4. So 1, 4. Notice that my x's have stayed the same. My y's, ooh, this is supposed to be a y right here, not a 1, sorry. My y's have been multiplied by 4. So that's a vertical stretch by a factor of 4. Because I've stretched the graph up. This would be where my normal parent function is. And I've taken the ends of this and stretched it up. And when I stretch it up, it gets skinnier.